Welcome to a tutorial on the semiconductor devices, and today in this tutorial we're gonna introduce y'all to this particular device over here that's termed as the Bjt. Okay, so you can understand that it should have a bigger name, so that's exactly what I'm gonna show you over here. So the first letter that we've got over here, that's B, stands for the term bipolar. Okay, so now next comes J, and it will basically be standing for the term junction, and finally this letter over here, that's T, would stand for transistor. Alright, so today our topic of discussion is the bipolar junction transistor, referred in short as the BJT. Okay, so now let me just tell you the main speciality of this device is that, it's got two types of current carriers. Okay, so back in the previous tutorials on the semiconductor, on the basic semiconductors, you had learned that there are two types of current carriers, namely the electrons, okay, and the other one, the holes. All right, so in this device, that's the BJT, both these electrons and holes, both the types of carriers are present together. Okay, so since they're present together in this particular device, so that's why this device falls under the class of bipolar devices. Okay, and of course that's why that's the exact reason why this term bipolar has crept into its name right over here. Okay, so that's a little bit of intro on the device over here, and now let's just quickly move on to its structure. So here we are, and now in this particular section we'll be basically be concerned with the structure and the various parts of the BJT device. Okay, so let's just bring up our diagram. Alright, here it is. So now you can see that we have a box, okay, that's basically a three-parted box. Okay, so there are three sections inside it. So the first section over here, which you can just see on the left of this particular diagram, okay, that represents the emitter section, okay, denoted with the symbol E. And then the middle one that you can see, that's of course the thinnest of all the sections that we've got in this light blue outlined box over here. That's referred to as the device's base. Okay, and of course the last one, that's the collector. Okay, so I'll just write it down. Write down their names over here. So this is of course the emitter. All right, and this one is the base. Okay, there we go. And finally the third one is of course the collector. Okay, so apart from these three sections which you can see over here, we have three leads sticking out of the device. So this is of course referred to as the emitter lead. Okay, we just symbolize with the symbol E over here. This is the base lead, again with B, and finally the collector lead, that's C. Okay, so other than that, let me just tell you that this light blue colored, or rather I'll just say that this light blue outlined box structure that you can see over here are basically is basically an extrinsic semiconductor material. Okay, so this entire box over here is basically an extrinsic semiconductor material. Okay, so it can be either a p-type semiconductor material, or it can also be an n-type semiconductor material as well. So now on this extrinsic semiconductor material, we've just carved, or rather the manufacturers, basically whoever manufactures these devices, carve out three basic regions. Okay, and now let me just tell you that the doping concentration in the emitter is comparatively the highest of all the three sections over here. So if I just write over here the doping concentration, okay, and write down the different parts of this particular transistor over here, that's the emitter and the base and the collector, and if you just put it all in a box, okay, then we'll see that the doping concentration for that of the emitter will be the highest, okay, that for the base will be the least, okay, and for the collector it'll just be intermediate. Alright, so I'm just gonna write down over here intermediate. Sorry there, little bit of spelling mistake, kindly don't mind at that. Yeah, that's right. So there you go. So we got the doping concentrations of all the three semiconductor sections that you know you can basically find inside that of a BJT. Okay, so with the emitter concentration, the doping concentration in the emitter being the highest, the base being the least, and the collector having intermediate concentration of all. All right, so that just completes the doping, the description of this device. And other than that, we can see the connection between any two sections is just separated by another blue line over here. Okay, that's just give rise to three different parts, or rather three different sections within this extrinsic semiconductor bar over here. And this particular lines, they just represent connections, or rather the meeting points of any two sections over here. So the meeting point between that of the emitter and the base sections is just termed as the emitter junction, JE in short. Okay, so I'm just going to write it down over here. So this just refers to as the emitter junction. Okay, yeah, there you go, that's junction. Okay, and also the connection, or rather the contact point between that of the base and the collector semiconductor sections is just referred to as the collector junction. Okay, termed in short as JC. So here JC would refer to as the collector junction. Okay, there you go. So now, apart from that, this is all that we had, we could basically make out of this structure of this transistor material over here. And the transistor material is not kept open with the semiconductor material on. So the whole semiconductor thing is just wrapped inside that of either a metal casing, or nowadays we can also have plastic casing as well. And then it's just in order to just make it prone to moisture and other impurities as such. So that's all from the structural section. And now we've arrived in the section where we are going to basically discuss about the various types of BJTs. Okay, so if I will write it down over here, let's say I just put this one in this sort of manner that let's say BJTs in the broader sense of the term, okay, or rather in general, we can divide BJTs basically into two large groups over here. Okay, so the first group that I'm going to talk about is the BJT that is of the PNP type. Okay, so it's a particular type of BJT. Okay, I'll just show you the diagram over here. Okay, there you go. So here, as you can see in this particular diagram, that as I had previously shown you, that the transistor basically, or rather BJTs basically have three different types of sections inside its extrinsic semiconductors, known as the emitter, base, and the collector respectively. So similarly, the PNP type of the BJT also has a similar structure, but here, if we are just classifying the BJTs based on their doping profile, then obviously there are two types of variants. So the first variant, that's PNP type over here. In this one, we are going to get the emitter and the collector will be made up of P-type extrinsic semiconductor material, while the base, that's the portion between the emitter and the collector over here, as you can see outlined in the pink, will be made up of the N-type of material, as you can see over here. Okay, so now apart from that, we have another type of BJT which is known as the NPN type of BJT. Okay, let me just bring the diagram. Yeah, there you go. So in this particular diagram, you can see that the NPN type is apart from the structure is concerned, is exact opposite of the PNP type. You can see over here that the emitter and the collector sections are made up of N-type extrinsic semiconductor material, and that of the base region, it is made up of P-type semiconductor material. So I can just write them down over here. So here the emitter for that of the PNP type, the emitter portion is just made up of P-type material, or rather P-type semiconductor, and as well as the collector, both the same. And now for the base, as far as it's concerned, is made up of, well, n-type semiconductor material. And similarly for the n-type over here, that's the n-type BJT that I'm talking about, we're gonna have the emitter, base, and collector sections as well. So the emitter and the collector sections will be just made up of, well, n-type extrinsic semiconductor material. Okay, while the base, that's the portion in between the emitter and the collector, will be just made up of the p-type extrinsic semiconductor material. Okay, so that's just is a summary of the broader way to classify BJTs. All right. And let me just tell you that since we are, or rather we frequently employ both the types of transistors in circuits, so obviously it's quite natural that both of them will have a different circuit symbol. So here I'm just going to show you the circuit symbol. So let me just name it over here, the circuit symbol. Okay. Alright, so let's just show you the circuit symbol over here. Okay, there you go. So here we have the diagrams for the respective PNP type and the NPN type BJTs as well. So you can see over here, well, that for the PNP type, okay, the collector, we should always remember that the collector and the emitter are made up of, well, p-type semiconductor material, while the base is made up of an n-type semiconductor material. And now we can just see that, well, the arrow mark given on the emitter lead, as you can see over here, is just directed towards the base of the BJT that we have seen under the PNP type BJT is concerned. So this particular arrow mark direction basically symbolizes the direction of current that should flow from the emitter towards the base, as the emitter is just made up of, well, let me just I'll just write it down over here. Since the emitter is just made up of, well, p-type material, same goes for the collector, and the base is just, well, made up of, yeah, write it down over here, n-type material. So whenever if we ever, well, manage to forward bias, or rather if we just, well, apply a higher potential at the emitter with respect to the base terminal over here, then we can well foresee that a current should flow from the emitter towards the base, and under this situation the base emitter junction would just be forward biased, and in that case, as in a diode, the current from the p-type semiconductor material, which is of course the emitter part over here, would just flow towards the base that is of course, well, made up of the n-type material. Okay, and similarly, if we just take a look at the NPN type semiconductor, I mean NPN type transistor over here, sorry for that. So in this particular type of transistor, the collector and the emitter, both the sections over here are made up with the n type of semiconductors, whereas that of the base section of this particular transistor is made up of p-type semiconductor material. Okay. And now in this particular, the circuit symbol of this BJT, we can well see that if we would basically forward bias the emitter junction over here, that's the junction between the base and the emitter terminals, as I said earlier, then in that case, well, if we need to apply a comparatively negative voltage on the emitter terminal with respect to the base terminal. So under this sort of a situation, it's quite obvious that the emitter junction being, well, forward biased, as that we've seen in case of a semiconductor diode, that the current would, well, obviously flow from the base towards the emitter, and that's what this arrow direction marks. So we can just well see that in case of, or rather in order to summarize, in case of PNP type transistor, or rather BJT, the arrow mark is directed from the emitter towards the base, and in the case of the NPN type BJT, the arrow mark is just reversed, that is from the base towards the emitter, as you can see the these two diagrams over here. Okay, so now that we have already discussed about the circuit symbols, and now we can well talk about the operational BJT. Okay, so all those who were just waiting for this time when you can, well, learn how to work with the BJT, or rather how to get it working, so this is the correct section for you all. Okay, so here I'm gonna show you how we're basically gonna configure BJT to work. Okay, so let me just tell you over here that in general, for a BJT to work, well, the emitter junction that is of course represented with the symbol JE always needs to be forward biased. Okay, so there you go. All right. And the other junction that we have in the BJT, that's the collector junction, symbolized with the symbol of JC. Okay, this needs to be reverse biased. Okay. So here, if you all would remember that the emitter junction represents the the semiconductor junction between that of the emitter and the base terminals, and the collector junction, that's JC, represents the junction between that of the collector and the base. Okay, so now that we know we have, well, two different types of transistors, that is the PNP type and the NPN type, and from this, from here on, well, whatever you've learned till now, you can well understand that the in order to forward bias or reverse bias these two types of transistors, in order to keep their junctions basically forward and reverse bias respectively, for the two different types of transistors, we would obviously require different sort of voltage levels at their respective terminals. Okay. Alright, so here you can see the diagrams concerned. So over here, if you just take a look at the PNP type transistor over here, you can see that, well, since it's the PNP type transistor, we need to obviously, well, forward bias the junction that occurs between the emitter and the base. So that's why we obviously, put a higher voltage, a positive voltage on that of the emitter terminal with respect to that of the base terminal. So we have a positive symbol on the emitter, negative symbol on the base. Okay. While in case of the biasing the collector, the junction between the collector and the base, okay, that's JC, we are putting a more negative polarity voltage on that of the collector with respect to the base terminal, so that this junction is, of course, well, highly reverse biased. So we can just write these, or rather just name these voltages. So the voltage level that's occurring in between that of the applied across the emitter and the base terminals are just referred to as, well, the emitter to base voltage, or rather in short as VEB. Okay, and here in case of the collector junction, the voltage drops that are occurring across the collector and the base terminals are just referred to as, well, in short as VCB, or rather the collector to base voltage. Okay, so I'm just going to write them down over here. So here VEB would signify that this is the emitter to base voltage. Okay, so I'm just gonna write it down over here, emitter to base bias voltage. All right, and that of, well, VCB refers to the collector to base bias voltage respectively. Okay, so collector to base, yeah, there you go, bias voltage. Alright, so there we go. So that's it from that of the PNP transistor, and how we all would connect it this way. How we all would connect it to voltage sources so that it becomes operational. And now if you just take a look at the NPN type transistor over here, so here the conditions are just reverse. We can see that since it's an NPN type transistor, so that the emitter terminal is, of course, of an N type, made up of an N type material, so as the collector. Okay, but the base is made of p-type material. Okay, so that's why we need to, of course, well, in order to forward bias the emitter and the base junction over here, we need to apply a negative voltage on that of the emitter terminal with respect to that of the base terminal, which is kept at a positive voltage. And then again, in order to reverse bias the collector to base junction over here, we are putting a more positive voltage on the collector with respect to that of the base. So here too, we can see that we're having, well, the VEB, that's the emitter to base voltage, that you're, bias voltage, which we can see over here, whose polarity is just reversed to that of the VEB in case of the PNP type transistor, while in the case of that of the collector to base bias voltage, it's VCB, we can see it's just the something different from what we can just see in case of the PNP type transistor over here. Okay, so that said, we have already reached the end of our tutorial and have given you the introduction necessary in order to, well, get you up and running with the basic concept of the transistor. Okay, so let's just see you in the next tutorial from now on, where we shall discuss about the other details as such. So it's just a short goodbye for now, and don't forget to catch us in the next tutorial as well. So till then, it's a short goodbye, and thanks for watching.